Hello, this is Swati Vavilapalli. This is the part 2 of my project explanation, multiple object detection using custom trained object detection classifier. For the part 1 at the end, I did not see that my video recorder closed the section, but I still went on. So I'll start from where I left off. So this is the snapshots of object detection in real-time video. We'll see the demo later at the end of the this video. So if you see the future work and sorry applications of this project, as I said, we can use this in self-driving cars to detect traffic lights, traffic signals, and other objects such as pedestrians or the cars. And then in medical field also this can be used as to detect cancer cells or tumors or blood cells types. And then even in video surveillance we can use it to find out the places we can see in the video, and the persons or the objects in the videos we can detect. And for a particular organization there will be employees. So if you want to detect your one of your employee face detection or the or face detection using at the entrance to detect the employee faces, you can use this application. So you can customize it according to your requirements. uh, then we'll move on to future work. So how we can improve this project is, right now in this project implementation I have used only 6 classes. Classes means that the types of objects I have trained. Here in this I have used the playing cards. So they are of type king, queen, jack, 9, 10, and ace. Only 6 of those, but it did not mention which type of the king it is. As you see, in a deck there will be 4 types of kings: hearts, clubs, spade, and diamonds. So I did not differentiate the kings. So you can increase the classes to 20 to 30 and then check the performance whether you're getting 94% of accuracy or more or less, how it is impacting the procedure or the performance. And then this implementation I have used, as I said, a faster RCNN Inception V2 model with Coco dataset. You can use this implementation in newer versions of YOLO because, as I said, according to the recent studies, newer versions of YOLO has more speed and very good accuracy also. So I just want to try with those also. And then I just want to conclude this present, this project with um, this is a very powerful multiple object detection model because for a particular user data set, according to the user requirements, if you want to build a model from end to end, you'll need a lot of time to train, and then you need a very big huge image repository. So without having those two, you can still train your classifier according to your needs and then detect the objects from it. As I said, you can use this in any field of object detection in cancers, tumors, video surveillance, or self-driving cars, or for any user requirement, you can use this method. So let's move on to a demo. I have 2 scripts, 2 Python scripts. This is for object detection in image. So as I have shown the flowchart, the algorithm in the previous video. So this is it. You just have to import the packages and then give the paths to the image and label map the neural network base model faster RCNN, and then get the get everything ready and then upload the image, apply TensorFlow, and then do the object detection. Then finally it will show the image with boundary boxes and the classes. See, you can see the classes and the scores here. So this is how we do it, but still I'm going to run this. Before that, I just want to show I have used the Anaconda prompt, and then I have created an environment. I trained the classifier already, which took like 9 hours, I don't know, 6 to 9 hours, I think. Then using all the build and setup, everything is ready. Everything is running right now. I just have to run the Python script and then wait for the output to be displayed. Uh, because this is a TensorFlow CPU version, uh, this whole detection process will be very slow because you know, right, this object detection method, it needs a lot of processing power, but since I did not have GPU with me, I used only CPU model. All the other applications running in my laptop will share the CPU processing time along with the object detection model. So that's why it will take a lot of time. And coming to these are not, don't panic because these are not something I need to be worried of, because these are just the warnings from the TensorFlow. I just need to change the version of the TensorFlow according to the object detection model. But when I did that, it was not working at all. So I left it like that. As you see, I have given an input image previously to the script without having these AS99, the classes and accuracy. I just gave a input image with the 8 cards in it. So as a output, you see, right? This is the A's card. It is a 99% of sure. The algorithm is sure it is 99% of A's. And then as you see, this is Queen 9 9, King Jack Jack, and 10. As I explained in the future work, these does not distinguish between whether it is a hearts one or a, see here it is a jack heart one, and then this is jack spade. I think so. Spade, I think so. So all these they don't distinguish, but still they distinguish it is A or 9 and how much percentage it is true, accurate. Now let's close this and then run object detection in webcam. So okay, this is the webcam. As I said, each frame in a video will consider it as an image and then perform the object detection on it, and then it will go again and take the next frame and then perform the object detection. So as you see, when you move your objects in the video according to the frame, it takes as input and then perform the object and the object detection, and then the output will display with the boundary boxes along with the name and then accuracy. So if we run that, it will take some 1 to 2 minutes maybe, because it's very slow. It's not because of the model I have used. It's not because of faster RCNN. It's solely because of I'm using TensorFlow CPU, because my laptop is slow. That's why it is slow. So while I'm waiting for the webcam on, I'll get ready with my cards. I have stick the cards in a book because moving here and there, I could not able to handle it. So I have stick the cards to it. As you can see, it is detecting Queen, Ace, 9, King, 10, Jack, and then let's see. In this, what I did is, see, 10, Jack. You just have to move around, and then when you are in a certain place, it will get as a frame and then it will display. So now I'm moving very fast. Okay. Let me just I think you have seen how it is going. So until unless I have stopped this process, it will go on recursion. I'm sorry. Okay. Okay. So this is it. So yeah, this is the demo of both. Okay, I'll close this. This is the demo of both object detection using webcam and then object detection using image. And if you see this, there are so many red lines. You don't have to worry about this because I pressed Control C to stop the input video. So that's why it is showing me as keyboard interrupt. And this is it. Thank you so much.